bottom three is the plus.
It's,
Top two.
yeah.
So when it's in like a row, it's kind of separate.
When it's in, it's not necessarily when it's in rows. It's just that we figure out that it's changing by twos. Changing by twos. So plus two, because I got that extra set of two. And then, so I have one set of two here, I have two sets of two here, and I have three sets of two here, because I want to relate this to these numbers down here. Since I have one set of two here, that gives me my 2n. And then my extra one is this loose guy. So we figure out how it's changing and see if we can make little patterns in that number of groups. Again, there's lots of ways to approach these. This is just one of those ways that I kind of see most people go or get successfully on it eventually. But these patterns just take practice, which is why we see these come up fairly frequently. So when we're trying to solve this, what do we do? What would we do to try and solve this? How can I figure out what n it's going to be?
Coach said to me, oh, well, first you're going to subtract the 1 from the 43, and then you're going to divide it by 2.
And then you're going to divide it by 2. So we'd have our 2n equals
And
42.
The answer is 21.
Because we subtract 1 from both sides. So then we divide each side by 2. Pattern number 21 would have 43 trees as the answer. So I've asked you how many trees were in pattern number 21. The answer would have been 43. Okay? So sometimes we're going to look at these patterns the way we have been looking at all the others, and sometimes I will give you a little twist. Okay? Questions on this one?
Woo!
They take practice. It's okay. So we are going to be in your workbooks. Shock.
What?
I know. Page 79. Oh my gosh. Because we are officially in chapter 2 now. So we're on page 79. And we're going to really take this into some story problems today. Yes, dear.
Okay. Can I come here to y'all's mom?
Yeah. Yeah. Oh, yeah.
Like, bro.
All right. So this is going to kind of mix together our solving stuff and some old school algebra, like systems of equations, that kind of stuff. But mostly it's going to be kind of equations that we just mush together. So we have here a kind of outdated situation because I don't think y'all download songs by the individual anymore. Used to have to do that because they were too big to fit on the teeny tiny iPods as a whole album, or it would take 3 days to download. So,
You know the amount of music you can fit on a gigabyte? I mean, 1,000 songs on it.
nowadays, yes, but before there was a lot of decent compression software built into that, it was not tons.
Well, that's because iTunes was kind of the first.
Yeah.
One of the first ones.
Right. But they kind of mastered that kind of compression stuff, and so we did actually download songs by the individual song, like back in the day. It was a thing. But we've got kind of pieces of this story in here. We've got 3 girls that downloaded a total of 36 songs. We know that Jane downloaded twice as many as Inez. Tracy wanted to have the most, being a diva, so she got 1 more than Jane. And we want to see if we can figure out how many each of them had. So there's a lot of information in here. We're going to try and write as many expressions as we can off of what we see. What is something we know in here? Do not throw your lollipop. There's a total of 36 songs. So we have a total of 36 songs. So I know if all three of them, so Tracy got some, Jane got some, Inez got some, we wound up with 36. So the way I would kind of write that as an equation is I would say that, Tracy combined with Jane combined with Inez, so adding them together, all together got 36. That totally works. The three girls had a total of 36. Added them together. What else do we know?
Jane has double or twice as many as Inez.
Yeah, Jane has twice as many as Inez. How could I write that Jane has twice as many as Inez?
2 in.
2 Jane.
Which one is twice? Which one do we need to multiply by 2?
Where?
Jane or Inez?
Jane.
If I take Jane times 2, is that going to equal Inez? Or is Jane the same as Inez times 2?
Inez.
Jane is the same as Inez times 2, right? She has twice as many. So Jane has twice Inez. So Jane has twice Inez. We can take these statements and kind of switch them, translate them into math. Twice as many as Inez means I'm going to take Inez and times her by 2. We have one more piece that we know. Diva. Tracy wanted the most, so she got one more than Jane. How can I say that Tracy has one more than Jane?
2I plus 4.
Say it again.
2I plus 4.
Beautiful. I'm going to write it in a slightly different way, but yes, that is 100% getting where we want to be. So Tracy has the same as Jane plus 1. That is absolutely valid. And then we also notice that, wait a second, I know a little bit about Jane. I know that she's the same thing as 2 times Inez. So I could write this in, again, even a different way. I could take this and think of this as Tracy being 2I plus 1. Because we know that Jane equals 2I, so I can do a substitution and substitute that 2I in place of the J. These two statements mean exactly the same thing. So we can do this in a couple of different ways. We do want to figure out what everybody got, how many they got. I am going to give myself a little bit more space to the right. So if we know this, that combined, Tracy, Jane, and Inez have 36. I'm just going to, hi. That's what happens when we start videos in the middle of class. All right. So I know some things that'll make this be something I can work with. I know something about Tracy. I know something about Jane. And I can get both of them to be made out of I's, made out of Inez. So I know that Jane is the same exact thing as 2 times Inez. So I can replace our Jane over here, J, with 2I. I can substitute that in. I can take my Tracy. I could either substitute this guy in with the J plus 1, or I could substitute in this 2 times Inez plus 1. I'm going to go with this one, because I would like to get this down to just having one letter over here. So for Tracy, I can write her as 2I plus 1. And then we still have our initial Inez kind of hanging out here for a total of 36. Now, ignoring all of the other context going on here, what can I do with this? Because it's better, question mark, because it only has one letter. Combine some like terms. I've got 2 I's plus 2 I's plus 1 I. How many I's we got? 5. 5 I's plus 1 equals 36. What can I do now to try and figure out what I equals? Minus 1. So we've got 5 times I equals 35. How can I figure out what I equals?
Log.
5.
Log.
5. So what does I equal?
7.
7. So in terms of this story, what does that mean? If we know I equals 7,
Each of them download 7 songs.
is it that each of them downloaded 7 songs? Who downloaded 7 songs?
Oh,
Inez did.
yeah.
Inez downloaded 7 songs. So how many did Jane download then? Or, yeah, how many did Jane download?
14.
14. How do we know she downloaded 14?
2 songs.
Because it's twice what Inez has. So Jane got, I'm not going to write downloaded again, 14 songs. So how many did Tracy have?
15.
15 songs. She had 1 more than Jane. Because Tracy is extra. And a really great way to kind of double check this is to say, okay, I know it's supposed to have a total of 36 songs. What is 7 plus 14 plus 15? What is 7 plus 14 plus 15? 36. So we have our total number of songs. Jane has double what Inez has, and Tracy has 1 more than Jane. So sometimes we just kind of dig through these paragraphs to find pieces. And we're going to practice that a couple more times on this page. But questions on this one? Because they're a little weird. Yeah, I'll reach best. Okay. Look at the next one and see if we can figure out an equation. My brain is broken. Here. Okay, here's the check.
Oh, yeah.
All right, so we've got a checking account that has an initial balance of $4,800. And $300 is removed each month for rent. They don't have any other actions on this account. This is just their dorm rent account. We want to know how many months will it take to reach $1,500. So I'm going to start dancing to somebody's headphones because I can hear it up here. What's up? How'd you get there? Walk me through it. Man, I know. How dare I? How'd you figure that out? I'm not saying you're wrong. I'm not saying you're right. I'm not saying you're wrong. Mm-hmm. Cool, cool, cool. So we know that this is kind of what we're aiming at. We know we've got our $300 that is being removed, and this is what we started with. So if I didn't want to just kind of brute force it or guess, how can I set this up? What are we starting with? 4,800. And what's changing? Oh, I did. Yeah.
We have
Eight-
300.
Yeah, know we're going to have 300 every month. Exactly right. So it's not just 300 once. We're going to have 300 times however many months. Every month I take away 300. So if I'm removing 300 every month, am I going to add or am I going to subtract? Subtract. We're going to minus.
Equals 1500.
And that we want to know what it equals to 1,500. There's multiple ways to get there, but I feel like this is one of the ways that kind of works well for a lot of people. I was like, I know some of us went different ways. That's totally fine. The only problem with trying to guess or brute force is what if it was, 37 or 48 and a half or 27 and a third. It's a lot harder to guess and check when we wind up with icky numbers. And we're not always going to wind up with nice, tidy numbers. So let's practice solving this thing old school style. How would we solve this, ignoring all context?
Do we want to subtract 4800?
We could absolutely subtract that 4,800. 100% valid. We can minus 4,800 from both sides of my equal sign. As long as I do it to both sides of my equal sign, I can do absolutely anything I want to. That's going to give us, do not be nice, our negative 300. Don't lose track of the fact that that's a minus sign. Negative 300m. What is 1,500 minus 4,800?
33. Negative 33.
Negative 3,300. Then we divide. Gorgeous. Dividing by negative 300. And that's another way that we get exactly what you had, which was 11. Because you were right. I just wanted us to explain. Negative 3,300 divided by 300 is 11. So in 11 months, his account's going to be getting low. So a lot of times, it's about finding the pieces in the paragraph. Sometimes they give us more information than we need. Sometimes they don't, but sometimes they do. Okay, so we just need to be careful and see what pieces we can find. We got one more to go. This one's going to feel a lot more like the first one than the second one. So it's going to feel a lot more like the first one. We've got Peyton is 3 years younger than Justin. Matt is 4 times as old as Peyton. And if we add together Justin, Peyton, and Matt, you get a total of 39 years. So we want to know each of their ages. How in the world should we start this? Aside from turning off our music. Peyton is 3 years younger than Justin. So how could I write that as an expression? Peyton is J minus 3. 3 years younger. Oh, that's not the highlighter. He's 3 years younger than Justin. So Peyton is whatever Justin is minus 3. You could also set it up as Peyton plus 3 equals Justin. It works as well. It's just a little awkward because it's not exactly how it's worded. What else do we know? Matt is 4 times as old as Peyton. So how can we write that down? Yeah. 4p equals m. 4 times as old as Peyton. So if I take Peyton times 4, I get Matt. What else do we know? If we add them all together, we get 39 years. So, we get our Justin plus Peyton plus Matt equals 39. That totally works. We can rock this. I have a lot of pieces here. This is going to be kind of where we start. Work with this guy. So I'm just going to rewrite it with our J plus P plus M equals 39. Because right now, I can't do much with this as it is right now. I can't add these together. I can't subtract by anything. But I know some information that I can change out. I know M is the same thing as 4P. So I could take this 4p and put it in place of m. I get my j plus p plus 4p equals our 39, right?
Yeah.
We could do that. I could then even come here and go, ooh, like terms, combine them together. I could absolutely do that and combine these like terms right here, because I know we have j plus, how many p's do I have here?
4p squared. Oh,
Not squared. We're not multiplying.
5p.
5 p's. Well now we're a little bit stuck again, because I have p's and I have j's. But what else do we know?
Peyton's 3 years younger than Justin.
I know p equals j minus 3. So I could put it in place of the p there. I could rewrite this as our, whoop, let me use the right pen.
J plus 5 minus 3.
J plus 5 times, and I'm replacing the p with our j minus 3. We can't just drop letters, but I can replace them if it helps. So I can replace the p with j minus 3, or I could go ew and add 3 to both sides and replace the j with p plus 3. But we can do this. Just be really careful. If we have 5 times the number, we need to make sure it's 5 times both of these pieces. We're going to distribute here. So we're going to have our j plus 5 times j, which is 5j. And then we also have our 5 times minus 3. What do we get there?
5j minus 15.
Minus 15 equals 39. So then I can combine some like terms together. I've got another set of like terms here. I've got lots of steps in this one. 1j plus 5j's means I get 6j's. Minus 15 equals 39. And you do not have to write as many steps as I do. I am doing like a half of a step per line, and that's okay. If you like this number of lines, go for it. You don't have to. But what can I do to figure out what j is?
N is 9.
Let's get there. We're going to add 15 to both sides. That's going to give me my 6j. Oop. Equals what? What is
9. Oh, shoot. 40. I think 54, I think.
I don't use our tools. 54. So what do we do to figure out what j is?
5 by 5.
Divide both sides by 6. So what is j?
9.
9. Ooh, that's a weird looking 9. So what does that mean up in this problem? What does j equals 9 mean?
That's how old Justin is.
Yeah, Justin is 9. So how old is Peyton?
6.
Because we know Peyton is 3 years younger than Justin. So Peyton is 9 minus 3. So Peyton is 6. So how old is Matt?
24.
Because Matt is 4 times Peyton's. So Matt has 2 T's in his name. There we go. So Matt is 6 times 4, which gives us 24. So we don't have to take this long to do it. Sometimes we can do substitution here. We can do these in a couple of steps. You don't have to take this many steps. This is just kind of the way we were saying it, and so that's the way I did it. Okay, so with these kinds of stories, we just need to be careful and make sure we're finding all our pieces. The first homework of this chapter is very much based on this, looking at equations and seeing if it matches the statements. So we'll say 4p equals m. Does that mean the same thing as Matt is 4 years older than Peyton? So it's seeing if the equations work. So we have about a little less than 10 minutes. And I'm going to give you time to work on it. Homework 1 for chapter 2.
Is that online?
It is on Canvas. Our homeworks are all on Canvas. So it should be up there and open. I'll pull it up and double check that we can pull it properly. But I'm going to give you time to work on it in class. I try and make sure you guys do have time to do the homeworks in here. That way you don't have to do any of them, at home. Because I know the likelihood of that happening is low. So, it looks, on my end, it looks like everything's set up right. 2-1, it says, does it match the equation? So I want to give you guys time to work on it. You guys can ask questions. You guys can work together. I don't really care. And that would be, now will be the time when you can use your phones and your stuff like that. So it's just like during the instructional time that you're not supposed to.